Alright, I'm John Thetford, and my webinar was on biogasoline. The technical title of it was Providing Energy to a Growing World, Biogasoline High Efficiency Engines. It was a Society of Biological Engineers webinar done in June 2011, and it was designed just to kind of give you basic economical and design parameters for a biomass fuel process. The speaker was Dr. Mark Holzapfel. He got his undergrad from Cornell, his PhD from University of Pennsylvania, and he was a captain in the U.S. Army. And while he was a captain in the U.S. Army, he developed a portable air conditioning system. And when you talk about that, you would think of something for a house. This was actually designed for chemical-resistant suits, which I thought was actually pretty interesting. For a small second, he mentioned a man named Richard Smalling. He won the Nobel Prize in 1996. He created buckyballs. Does anyone know what buckyballs are? They're the spherical form of carbon. To begin the economical section, he began to tell everyone how there are top 10 human problems. Number one is energy, 2, water, 3, food, environment, poverty, terrorism, war, disease, education, democracy, and population. And he immediately went to this. He claimed that everything can be solved with clean, affordable, and abundant energy. Doesn't matter what your problem is, it can be solved by that kind of energy. So essentially, all of these are energy problems. The driving forces for this need in energy is a growing population. For example, he stated in 10,000 BC, the approximate population of the world was 4 million people. In 2011, it was 6.92 billion. The rising standards of living, for the majority of people in the room, you were born in the 90s. China was poor at the beginning of the 90s, and now they are one of the largest economic driving countries in the entire world, next to India. Both of them are about tied right now. He then talked about oil imports, which I have on the other slide, peak oil and global warming. Peak oil is according to Hubbard's peak, which is a system that a man derived to create when the peak in oil price was going to occur. And he actually ended up being very accurate within months of it happening. In 2009, the U.S. oil trade deficit was, they would consume 19.1 million barrels of oil a day. We would import about 59%, and the cost was about $100 per barrel. That comes down to $1.1 billion a day just for oil. That's $400 billion in a year, and our deficit for trade in the entire U.S. of all trade was $379 billion that year. So just with oil, we could have paid off our deficit and actually made a profit. He says all of this is due to energy. Crude oil in 2009, like I said, is $100 per barrel. About $125 for fuel is what you would sell it for. So that's a $25 profit. For biomass, it's about $20 a barrel, he claims. And you could still sell it. Notice he's not being ignorant and saying, we'll give people a cut. He's saying, we're still going to sell it for $125 a barrel, and that's a $105 profit. He then went to the process part, which he talked about one of the most common and is actually a rather efficient process called the Mixalco process. It starts with a pre-treatment, a fermentation, a clarification, which some people overlook that process, go to dewater, thermal conversion, and then hydrogenation. And from there you choose what you need to do according to the type of fuel you're making. In the pre-treatment, you remove the lignin, which is like the paste that holds the biomass together. He would use, in the process he was talking about, he used lime to break apart that. That way you could actually, begin to use that biomass. And the fermentation, he claimed that it favors organic acids because of their higher energy produced. And he said that it was like the rumen in cattle, which is it's like in the intestinal stomach system. I don't know if y'all know that stuff. And he used this example as glucose converted to acetic acid, and that's the organic acid. And he compared it to glucose to the common ethanol. And the difference was over 13 calories in energy difference. And the dewater, he talked about how they use heat exchangers and compressors. And I found it remarkable because he used a system with these numbers, and he said it was actually served a purpose to use the heat exchangers to create it just at 1 degree higher, and a compressor just to make 0.04 higher pressure. And that was actually viable for their use. For thermal conversion, it's just using heat to create reactions to change the compounds. He talked about using possible calcium acetate and creating acetone. And it requires heat to start that reaction. In hydrogenation, you then just take the ketones that you created in the middle of your process and you convert them to alcohols that you want to use. They claim the advantages of the mixed alco process was the use of wet feedstock, wide range of feedstock where you can use multiple things to feed into your system. It's efficient when it comes to energy use. It does not require genetically modified organisms, which actually would jack up your price quite a bit. It can be created for multiple products, and the process can be distributed. And then also, just like genetically modified organisms, if you had to add enzymes, your price would also go up. This is then where I got confused. He said that with this process, it competes with oil at $65 per barrel. So it's kind of already going back from that $20 earlier. Ways I thought he could improve this webinar was to give more of a reason and the importance of Richard Smalley. He didn't really what I told you is what he said. So I'm assuming the spherical form of carbon has something to do with biomass, but he doesn't really tell you that. He assumes that the people viewing this webinar have a certain level of knowledge when it comes to this subject. Then also, I think he should explain how the aspects of the alco process are done and the reasons for each. He just kind of flew through it. It was only about 12 to 13 minutes of the 50-minute slideshow. And then I said, don't take up a third of the time showing personal pictures. He works for a company called Rotorstar Corporation, and he just showed like pictures of him on a site, and then a picture of him with his family and talking about it and stuff. And it does not really inform you. And he took that from 34 to 48 on that, and 20 minutes of it was just for the economical uses of biomass. And that's it.